Hi everyone, we just want to have a look at circle relations. So by circle relations I mean graphs that look like so. And based on earlier work that we did in chapter 4, we know that this is a many-to-many relation. And if we use our vertical line test, we could clearly see that it's not a function, as my perfect vertical line cuts the graph or our sketch more than once. So if you remember, the vertical line test is a test that we could use with any graph that we sketch. If it only cuts the graph once, it means that it's a function. In this case, it cuts the graph twice, so it's not a function. Okay, so our basic rule for circles is x squared, oops, I should get my pen, x squared plus y squared equals r squared. Okay, so r represents our radius, and if for a circle with an equation given like so, the center of the circle should be at 0, 0. So let's look at an example. X squared plus y squared equals 4. Okay, turn it into our original form where it's x squared plus y squared equals r squared. So see here how it's r squared. We need to turn the 4 into something squared, so obviously that's 2 squared. So when it's in this form, it's very easy to sketch. Y-axis, x-axis. The center of the circle should be at 0, 0. And we could see here that our radius will be 2, not 4. I must turn the 4 into a square number, so 2 squared. And we'll have a radius of 2. So that would be 2. Negative 2 over here, and positive 2 over there. Okay, let's do another one. How about if we have x squared plus y squared equals 5? Now this is a little bit trickier because we know that 5 isn't a square number, so I need to express it as x squared plus y squared equals square root 5 squared, as square root 5 squared will just give me 5. Okay, so how do I draw that? Again, sketch my axes. Okay, in this form, the center of the circle is at 0, 0. Excuse me. And this time our radius is square root 5. So not 5, we need to turn it into index form with where we have a square number. So square root 5 squared will give us a radius of square root 5. Whoops. Okay, so this time our radius is square root 5. So again, we can't say our radius is 5. I could turn 5 into the square root of 5 squared, and our radius is now square root 5. So it's really important to remember that we want to graph these easily. We need to use the form, just get rid of that, x squared plus y squared equals r squared. That's really important over here. Okay, now sometimes we only want to draw the top half of the circle or the bottom half of the circle. So if I split my page in two, like so, say we want to just draw the top half of the circle, and over here I want to draw the bottom half of the circle. So this circle should touch the end there, but there are limitations with the pen that I'm using, so please bear with me. Okay, so if I want to draw the top half, then our equation is y equals the square root of r squared minus x squared, and for the bottom half, y equals negative square root r squared minus x squared. So if we remember from last week, this negative here means that we reflect our graph about the x-axis, so our x-axis becomes our mirror. Again, in this form, the center of the circle should be at 0, 0. Let's have a look at a really quick example for that. So say we have y equals the square root of 16 minus x squared. We know that the form that you would have just seen is y equals square root r squared minus x squared. So I need to turn this 16 here into something squared because that's what our original rule has. And that's quite easy. Y equals the square root of 4 squared minus x squared. Okay, very simply, draw my axis, y, x. There is no negative in the front here, so that means that we will be looking at the top half. The center of the semicircle should be at 0, 0, as it is there, and we have a radius of 4. Remembering that r is our radius. So it goes to 4, negative 4, and positive 4 up there. So far we've looked at circles where the center of the circle is at 0, 0. Okay, now let's look at the equations of a circle where the center of the circle is not at 0, 0. Our basic equation is given by x minus h squared plus y minus k squared equals r squared. Oops, that's a funny equal sign. Let's put that again. Okay, now you would immediately recognize the r squared. The r is our radius, so if this number was 16, we will turn it into 4 squared, so our radius is 4. And we've done that in the previous section. Okay, you will immediately recognize as well the negative h and the negative k, and they're responsible for our translations. So x minus h, you guessed it, that's responsible for horizontal translation. And y minus k is responsible for vertical. Excuse the handwriting of this pen. Okay, so vertical translation, it's a very funny vertical there. Okay, so horizontal translations and vertical translations there. So if our equation has a minus h and a minus k, so where's my highlighter here? A minus h and a minus k, then our graph can look like this. With that center point there is h, comma, k. Okay, so what happens is if this is negative h, we move at h units to the right in the positive direction, and if this is negative k, we're going to move at k units up in the positive direction. And let's go through one of those examples. Alrighty, let's look at an example. Say I've got x minus 2 squared plus y minus 3 squared equals 2 squared. Okay, looking here, I could see that the center of my circle is going to be at positive 2 and positive 3. Remember, I have to switch this sign. Why? Well, let's have a look. If I draw my axes, my perfect Cartesian plane there, a normal circle would have an origin, the center at the origin, which is 0, 0. So following those dots there. Okay, that negative 2 means I'm going to move this circle to the right 2 spots. Okay, and the negative 3 here means that I'm also going to move it up 3 spots. So I get it roughly here, and the circle, whether it's going to be here or like this, depends on my radius, and my radius is 2. So how would I go about drawing this? Well, the first thing that I know is that the center of my circle is at 2, 3. Now, because I don't want to draw a dodgy circle with my pen, I'm just going to put a circle from my template here. Okay, obviously yours won't be shaded in. And I'm going to write over it in black. Okay, so we said the center of the circle is going to be at 2, 3. So if I zoom in, the center there should be at 2, 3. Okay. Now, looking at this equation, I could see that my radius is 2, which means that the distance from the center of my circle to the edge, horizontally and vertically, and every other way because it's a radius, is 2 units. So from here to here is 2 units, so moving from x equals 2 to the left gets me to x equals 0, which hits my y-axis. And moving from x equals 2 in the middle to the right 2 units moves me to x equals 4. So my circle finishes at x equals 4. I'm going to say that again. We could see from this equation that the center of my circle is at 2, 3. Okay? We know that the radius is 2. So looking at the x-coordinate, which is 2 here, if the radius is 2, I'm going to move 2 spots to the left, which is 0, and 2 spots to the right, which is 4. Okay? What about vertically? We could see that the center is at y equals 3, over here. If we move 2 spots to the right, 2 spots up, 2 plus 3 gets me to 5, and 3, take 2 gets me to 1, over here. We'll say that one more time. So looking at the y-coordinate, the center of my circle is at y equals 3. If I move 2 units up, because my radius is 2, I get to 5. If I move 2 units down, because my radius is 2, I get to 1. So obviously, because you're going to do it to scale, or might be good to use graph paper, you could put these coordinates and then draw your circle. If I wanted to look at the domain of this graph as well, let's just move it over here. The domain of the graph is from 0 to 4 inclusive. So my graph, the domain of my graph is from 0, x equals 0, because this side is at x equals 0 and this side is at x equals 4 inclusive. So all those values in between apply. And my range is from 1, the lowest point of my graph is 1, and the highest point of my graph is 5. Okay? So the very important point to take from here is that this minus 2 moves my graph 2 spots to the right, and this minus 3 moves my graph 3 spots up. So originally, if it was at 0, 0, it would be here. What we did is we moved it 2 spots to the right and then 3 units up. So I really hope this video helped, guys, and please see the schedule on Edmodo to see when the morning classes are for some extra help.